Hello everyone, welcome back to lecture series on data structure. In this session we will be continuing implementing the linked list, and the operation that we will be performing on the linked list is to remove the last node from the list. Now let us say we are having the list comprising of 5 nodes n1 to n5, and the objective is to remove the last node, that is we want to remove node n5. Okay, now to start with this, the very first thing that what we will do is, before we are removing any node, whether we are removing the first node or the last node or any intermediate node, very first thing what we will check is whether list exists or not. Okay, that we will check it by checking the status of head node. That is, if head is equal to null, that means list do not exist, list is empty, nothing to remove. Else, now we look into this. Now we want to remove the last node. Last node is identified when the next pointer of that node is null. So what we will do, in order to reach to that node, let us say we are taking one pointer m. That m will be of the same type as that of a structure node. So we will create one structure, a struct node. Okay, and that pointer name is m. So what we'll do, we'll traverse this m starting from head. That means m equal to head. The moment we say m equal to head, that means m is pointing to the first node of the list, and then we'll traverse this m from start till the end of the list, and end of the list is identified when next pointer is null. Okay, so we'll try to reach at n5. Okay, so this is where after traversing m will reach, and once we reach at n5, that is end of the list, we will delete m. So the moment we delete m, that means we remove the last node. And to identify when the list is getting end, or what is the last element of the list, what we'll do, we'll make next pointer of the previous node, that is node n4, to be null. Okay, that means along with this node m, we require another node that will be just one node before the node m. So if m is at 7th node, node n will be at 6th node. Okay, so in addition to node m, we'll take another node, that is n. Okay, now we'll go like this. We are traversing the list starting from head till the end of the list. End of the list in the sense when the next pointer of n, or next pointer of that particular node, becomes null. So we'll go like this: while next pointer of m is not equal to null. If next pointer of m is not equal to null, then we'll say whatever the current position the m is holding, that is now identified by node n, and m moves ahead. M moves ahead by using its next pointer. Okay, so let's check with this. Let us say we are having the list, that is 10 to 20, 20 to 30, 30 to 40, and let us have one more element, that is 50, and after 50 there is no other element, so next pointer at 50 will be null. Initially we say m is equal to head. So the first element, which is identified as head, now also is getting identified by m. Okay, now as per this logic, while next is not equal to null, next of which, next of m pointer, while m next is not equal to null. So what we are doing, n equal to m, and m moves ahead. So let's check with this. We are at node 10. Okay, so that 10 is getting identified by m. So whether next pointer of 10, or that is m, is equal to null? No. So what we will do, we will assign n equal to m. So this is now getting identified as n, and m moves ahead, m equal to m next. Now we are at node or second node whose value is 20. So now again here we'll check whether the next pointer of 20 is null. No, it is pointing to 30. So n is equal to m. So n comes over here. Now this is where your n is, and m moves ahead. Now again at 30 you will check whether next pointer of 30 is null. No. Then now m comes over here. Now our node n is pointing to 30 and m moves ahead. Again at 40 we are checking whether the next node of m is null. No, because it's pointing to node 50. So now we'll move n, we'll say n equal to m again, because this is where this is the first statement, and then m moves ahead, m moves to 50. Now whether next pointer of 50 not null? No, it's a null, so this loop will break. So at the end of this loop, node n is the second last node and m is the last node, so we have to delete that last node. Or now to delete that last node, what we'll do, we'll use the delete command so that the node itself will get destroyed and memory will be freed. Now before doing that, what we'll do, we'll set next pointer of n equal to null. The moment you say next pointer of n equal to null, then your list will be something like this. You are having 10, 10 to 20, 20 to 30, 30 to 40. After 40 you are having null. N is pointing at this location. As far as your m is concerned, you are having the node 50, but that node is nowhere in the list. That's an independent node. Okay, but we do not require this node, so we should free this. So what we'll do, we'll just destroy that node. A node or nothing but that, again that's a pointer. We'll destroy that pointer by using delete function. So we'll say delete m. So now if you will try to display the list, your list is same, that is starting from 10 and ending down till 40. Okay, so let's try to have one small program on this. Not program, what we'll do, we'll continue with the existing program that we are doing since last sessions. So let me save this first file. Okay, now here is the editor. The function that we will be implementing is we'll be removing the last node. Okay, and one more thing, in the previous session we missed that whenever we are removing any node, whether we are removing the first node or whether we are removing the last node, we should reduce the number of nodes. That means this counter is there, the counter will get decremented by 1. Okay, so let's check with this first. Let's add that function to remove last node. So along the options, what we'll do here, let us make one change. Cout here, 7th option is remove last node. Okay, and then 8th option will give it as quit. Is this proper? Yes, I think there's space over here. All right. And so 7th option, case 6 was this one, so we change this to case something wrong along this. Okay, 5, then this will be 6 and this will be 7. So after 5, when we are going for case 6, okay, so remove last, let this be the function through which we are going to remove the last node. Here it will be break, and correspondingly this will be node or case 7. All right, so let me copy the name of the function. So we are removing the last node, so let me add this function over here, void remove last. Okay, so very first thing what we'll check, whether your head is null. If head is equal to null, okay, if head equal to null, that means there is nothing to remove. So cout \n list is empty, nothing to remove. Okay, then after this the else part, that means there are few nodes. Okay, now here what we'll do, what if the first element itself the last element. We are trying to remove the list. Okay, we are trying to remove the last node. This is accepted. We are checking into this condition, that is if head is null then list is empty. But what if there is only one element? What if there is only one element? That means you are trying to remove the first element itself. Whatever the list you are having, that first element is your last element. Then in that case, what we will do, if head next equal to null, that means there is only one element in the list, then we'll simply say head is equal to null. We have added only one element, and that one element or the first element itself is the last element. So if you are trying to remove the last element, that means you are trying to remove the head only. But anyways, we cannot destroy head directly, so we have to say head is null. Else, now there are multiple nodes. Okay, then what we'll do, we'll take two dummy nodes, m and n, struct node asterisk m and asterisk n. We'll follow the same concept. Let me rearrange this. We'll go as per what are the theory we have discussed over here. Okay, so let me elongate this 1 second. Okay, now what we'll do, initially we'll say m equal to head, then we'll traverse. The moment we are saying m equal to head, that means you are at this location at the very first point. If 10 is the first element in the node, that at 10 head is also pointing as well as m also pointing. Now we'll move or we'll traverse the list by using node m till we reach end of the list. End of the list is obtained when the next pointer is null. So while m next is not equal to null, not equal to null in the sense there is some next node, what you do, you set n equal to m and you move m to next list or next node by using the pointer next itself. So at the end of the list, what you will have, you will have node n pointing to the second last node and node m pointing to the last node. Once you reach at this step, then what you do, you make the next pointer of second last node to be null, indicating end of the list. So n next equal to null, indicating the list is, that is the end of the list. But still you have some memory utilized due to node m, so free that by destroying that node m. So delete m. Finally, either whether it's your first node or last node, the number of nodes are getting less by 1. You are removing one node, so c minus minus. Okay, now let me just compile it and execute it. Let me save. We can do directly from here. Just expand the workspace, you will get some symbols over here. So this is for build. If any error, it will be over here. And now let's execute this. So here we go. Okay, so we are saying add at first option. So we add 10. Then again we will go with the first option to add at first. We add number 20. Now we go with the second option to add at last. Here we say 30. Still we will go with one more option to add the element at last. And now we add 40. So if we look into the list, if we display the list, it will 20 to 10, then 30 and 40. So let's check into this. We go to the fourth option, display, and here we get 20 to 10, 10 to 30, 30 to 40. Now what we are going to do is we are trying to remove the last node. Okay, last node is 40. So let me give the option as 6, and at 6 what's happening, the 40 is getting removed. Okay, we are not displaying anything over here, but let's check over here. Yes, we are not displaying anything. We are just deleting m. Actually we should have given one statement, that is node removed. or item removed, that is the value of x of node m. But anyways, we'll display the list again. So if you display the list with option 4 over here, we get this. So previously list was having 20, 10, 20 to 10, 10 to 30, 30 to 40. Now you have removed element 40, so that is not getting visible. So we'll just modify this code. Before we delete the value or delete node m, we'll give one statement, cout \n element removed or node removed, element removed, node removed, or whatever it may be, element removed the element which we are removing is the last. So last node is identified by m, so m x, member is x. So this will get displayed, and after getting this, you can call upon this method so that it will get displayed at the same time, the way we did in the previous session. And one more thing, we missed one topic in the previous session, that was this. So whenever we are removing the first node, okay, your counter will, again the number of nodes will get decreased. So what will happen, before this I make that change, the same whatever we did over here, while we are removing last node, we are reducing the number of counters by 1. Same thing I have done over there. So now let us rebuild and re-execute this. Okay, so first I am going to first choice I'm going to do is to add at first. Okay, so I'm adding 10. Then I'm going for the second choice, that is add at last, so it's 20. Okay, then I'm going for the next choice, that is add at first, and here I'm at 30. So now my list consists of 30 to 40, 30 to 10, 10 to 20. And now let us go for the last. I go for second option, that is add at last, and here I give the value as 40. Now let me display the list. I'm going with the fourth option. With fourth option we get like this: 30 to 10, 10 to 20, 20 to 40. Okay, now what I do, I go with the sixth option. That's what this session is about, to remove the last node. So I give the option 6, and here you get element removed 40. Okay, because that's last element. And now list consists of 30, 10, 20. Okay, I again go with the same option, that is remove the last node. So now what happening over here, element removed is 20, so the 20 got removed, and we are in the list, we are having 30 and 10. Let us go with one more. I remove the sixth, I go with the sixth option. So element removed is 10. You are in the list, previously we are having 30, 10. So now we are having with 10, 10 got removed and left with only node 30. Let me remove this also. So I'm going with the sixth option again. Now element removed is 30. Now as you are removing the element, there is nothing to display. Okay, so now if we go if we display the list, it will say nothing to display here. That's it. Okay, so that's it for this session. In the case you have liked the video, kindly hit like and subscribe. In the next session we'll look into how to remove the element from any particular position. Okay.